Category 6 cable, commonly referred to as Cat6, is a standardized cable for Gigabit Ethernet and other network physical layers that is backward compatible with the Category 5/5E and Category 3 cable standards. Compared with Cat5 and Cat5e, Cat6 features more stringent specifications for crosstalk and system noise. The cable standard provides performance of up to 250 MHz and is suitable for 10 base T, 100 base TX, 1000 base T/1000 base TX and 10 GBASET. Whereas Category 6 cable has a reduced maximum length when used for 10 GBASET. Category 6A cable is characterized to 500 MHz and has improved alien crosstalk characteristics, allowing 10 GBASET to be run for the same distance as previous protocols. Category 6 cable can be identified by the printing on the side of the cable sheath. Cat6 patch cables are normally terminated in 8P8C modular connectors. If Cat6 rated patch cables, jacks and connectors are not used with Cat6 wiring, overall performance is degraded and will not meet Cat6 performance specifications. Connectors use either T568A or T568B pin assignments. Although performance is comparable provided both ends of a cable are the same. Category 6A, the latest standard from the TIA for enhanced performance standards for twisted pair cable systems, was defined in February 2009 in ANSI TIA 568C1. Category 6A is defined at frequencies up to 500 MHz twice that of Cat6. Category 6A performs at improved specifications, in particular in the area of alien crosstalk as compared to Cat6 UTP, which exhibited high alien noise in high frequencies. The global cabling standard ISO IEC 11801 has been extended by the addition of Amendment 2. This amendment defines new specifications for Cat6A components and Class EA permanent links. These new global Cat6A Class EA specifications require a new generation of connecting hardware offering far superior performance compared to the existing products that are based on the American TIA standard. The most important point is a performance difference between ISO IEC and EIA TIA component specifications for the next transmission parameter. At a frequency of 500 MHz, an ISO IEC Cat6A connector performs 3 dB better than a Cat6A connector that conforms with the EIA TIA specification. 3 dB equals 50% reduction of near-end crosstalk noise signal power. See 3 dB point. Confusion therefore arises because of the different naming conventions and performance benchmarks laid down by the international ISO IEC and American TIA EIA standards, which in turn are different from the regional European standard, EN 50173-1. In broad terms, the ISO standard for Cat6A is the highest, followed by the European standard and then the American. Maximum length, when used for 101,000 base T. The maximum allowed length of a Cat6 cable is 100 meters or 328 feet. This consists of 90 meters of solid horizontal cabling between the patch panel and the wall jack, plus 10 meters of stranded patch cable between each jack and the attached device. Since stranded cable has higher attenuation than solid cable, exceeding 10 meters of patch cabling will reduce the permissible length of horizontal cable. When used for 10 GBASET, Cat6 cable's maximum length is 55 meters in a favorable alien crosstalk environment, but only 37 meters in a hostile alien crosstalk environment, such as when many cables are bundled together. However, because the effects of alien crosstalk environments on cables are difficult to determine prior to installation, it is highly recommended that all Cat6 cables used for 10 GBASET be electrically tested once installed. With its improved specifications, Cat6A does not have this limitation and can run 10 GBASET at 100 meters without electronic testing. Installation caveats: Category 6 and 6A cable must be properly installed and terminated to meet specifications. The cable must not be kinked or bent too tightly. The wire pairs must not be untwisted and the outer jacket must not be stripped back more than 0.5 in. Cable shielding may be required in order to improve a Cat6 cable's performance in high electromagnetic interference environments. This shielding reduces the corrupting effect of EMI on the cable's data. Shielding is typically maintained from one cable end to the other using a drain wire that runs through the cable alongside the twisted pairs. The shield's electrical connection to the chassis on each end is made through the jacks. The requirement for ground connections at both cable ends creates the possibility that a ground loop may result if one of the networked chassis has a different instantaneous electrical potential with respect to its mate. This undesirable situation may compel currents to flow between chassis through the network cable shield, and these currents may in turn induce detrimental noise in the signal being carried by the cable. Category 6E. Following the finalization of Cat6, a number of manufacturers began offering Category 6E cables as an enhancement to the Category 6 standard, presumably naming it after Category 5E. However, no legitimate Category 6E standard exists, and Cat6E is not a recognized standard by the Telecommunications Industry Association. While all Cat6E cables presumably meet Category 6 standards, the actual increase in transfer speeds and the maximum cable length varies from manufacturer to manufacturer owing largely to the lack of an industry standard. See also, Ethernet crossover cable, references. External links, 10 GB per second over copper, horizontal cabling choices. The Siemens Company January 10, 2006 Information on cable construction and alien crosstalk mitigation. Schmidt, John. Determining the right media. BICS News 28 Information on TIA-TSB 15537M versus IEEE 55M limitations. How to make an Ethernet Cat5e Cat6 cable. Cable and Wireless Technologies, Incorporated October 14, 2009 How to terminate Cat6 shielded keystone jacks. Cable and Wireless Technologies, Incorporated December 9, 2009 How Category 6 cable is made. Cable and Wireless Technologies, Incorporated November 5, 2009 What really changes with Category 6? The Siemens Company. Retrieved January 5, 2013 A.